So those are a brief introduction of the ARM process and differences between RISC and the CISC. Let me show you in which product you can find ARM processors. So that's the iPhone 11. It has A13 chips, which is manufactured by Apple. So it has 6 ARM cores. So, and the ARM cores are type A. We will be using type A, which is advanced type of the ARM processors in our lab. So we will talk about the different types of ARM processor later on, but just give you a brief introduction in which products, some of the products that you can see ARM processor in it. So that is another chip which has Amazon Echo, Alexa. Okay, so it has several ARM Cortex A, A8, A7. There would be different version of the type A processor. And then there would be Kindle HD file. So it has a dual core processor which contain 2 ARM processors inside this Texas Instrument chip. It has a Fitbit smartwatch. So it has a ARM Cortex M, which is defined as a microcontroller. So, and it has M3 that is inside the Fitbit. For the textbook that we will be using in this course, it uses the Cortex M, but in the lab we are using the Cortex A, which is advanced than the Cortex M. Most of these two have this most instruction sets, so we'll talk about the differences between them. And you can see another smart watch, Samsung Galaxy. It has a Cortex M4, so that would be different versions of the M. So it has another smart watch, and that would be Cortex M3 microcontroller unit. So microcontroller would be contain microprocessor and memory and peripheral devices. We will talk about it in more details later on. That would be Oculus virtual reality just headset. So, and that it's a Cortex M0 RISC core microcontroller. So it's bought by Facebook or Meta. So, and then that would be another virtual reality, HTC Vive. So that contains M0. The advantage of having ARM processor, it has a low power consumption, which will be more suitable for resource constrained environments such as smartphones, virtual reality headsets, and since these days there are a lot of computation should be done inside the microprocessor, and then the power consumption would refer to the battery life of your computer or microprocessor-based system. So having lower power consumption, it would be very, very attractive as compared to the old microprocessor, for example, Intel. So when the Intel was designed at the long time ago, and they didn't think that microprocessor may be used later on in the small devices. So they, since it was used in the computer, they didn't care about the power consumptions. And later on, as the technology advances, then the processor and computers would be fit inside the small devices. And then for those small devices, some of them would use battery. So, and then they use the power consumption would be the main challenging. So the ARM processor is designed so that it has a low power consumptions, and one of the key features of having a RISC processor as compared to the CISC processor. The Intel processor is a CISC processor, whereas the ARM processor is a RISC processor. So, and that would be another microcontroller. So Nest thermostat, which is a smart thermostat, has a Cortex M3 microcontrol unit, and that would be another just a smart watch. And let's briefly talk about the memory. So I'll talk about the memory in more details in the next unit, but just briefly explain about the memory. So as you see, the memory that is shown here, we define it as a set of the locations of the memory. So memory here is the memory. So each address has just a location. So we have a 32-bit address bus. So bus would be the total number of bits for the processor. So and that would be referred to the different locations of the memory. So since we have a 32 bits and 32 bits would have 2 to the power 32-bit different combinations, and each location has a unique address. So and that would be 32 bits. So it's is represented by hexadecimal number. So it's going to be 8 hexadecimal numbers. So the minimum address would be all 0, and the maximum address would be all F. So that would be 32-bit address. And for each location holds a byte, so we call the byte addressable. For example, the memory location at the address of, let's say, this address contains the value of this byte. So that is going to be the hexadecimal representation or 8-bit representation of the value inside the memory. So that is a hex 70, which is equivalent to 112 in decimal. And so the number, the total number of locations in the memory is limited. So that's a huge number of locations. So as I mentioned, that would be 4 gigabytes of the RAM or random access memory, or in general memory. So, as I mentioned, since we have a 32 bits and 32 bits has a total combination of the 2 to the power 32 locations. So, and we define a gigabyte, giga, as a 2 to the power 30. So, and the gigabyte would be 2 to the power 30 bytes. So, since we have 2 to the power 32 locations, and then that should be multiplied by 2 to the power 2, which would be 4. So, as a result, we will have a 4 gigabyte as a total number of different locations of the memory with a 32-bit location. So as I mentioned before, we will talk about the memory in more details in the next unit. But for now, so we can write it 2 to the power 32 as a product of the 2 to the power 2 times 2 to the power 30. And then 2 to the power 2 is 4. 2 to the power 30, we define it as a giga. Okay. So, and then 2 to the power 32 location, and each location would be byte, so it's going to be 2 to 4 gigabyte, as you can see here. Okay, so we define different notations in the memory, so usually 1 kilo is going to be 2 to the power 10, okay, which would be 1024. Okay, so and then the next one would be 1 mega, which is defined as a 2 to the power 20, and the next one would be 1 giga, which is 2 to the power 30. Okay, so 1 kilo is around 1,000, but it's not exactly 1,000. It's 1,024, and similarly for 1 mega. So 1 mega is going to be 1 kilo to the power 2. So that's these notations would be used in the memory. Okay. And then what would be the values inside each location of the memory? Okay, so that could be either the program data, which we call it the operation code or machine code, or the program instruction or program data. Okay, so the instruction, we call it machine code or opcode. So for example, 70 might be the code used to tell the processor to add two values together. So that instruction code or program code or machine code, they are the same names. So that would be just a different bit patterns, which has a meaning to the CPU or processor. And when that kind of bit patterns will fetched inside the microprocessor. Then the one part of the microprocessor, which is called control unit, would be interpreting that pattern, and then based on what is designed, then it will obtain what has its meaning. So